Step costs are costs that increase stepwise as potential volume increases. For example, say you have one machine that could produce 30 units and has a fixed cost of $1,000. And now you're thinking about buying a second machine. If you buy a second machine, this means that you can now produce up to 600 units if you take on an additional $1,000 of fixed cost coming from the second machine. With one machine, your fixed cost and your total cost, we saw this in a previous video, looks like this. As soon as your second machine goes live, your fixed cost increases, like a step, and its total cost will look something like this. In these types of scenarios, you'll need to, number one, determine the break-even point for each machine, and secondly, take note of the number of outputs. Let's now take a look of an example on page 204 to make this concept clearer. When analyzing the alternatives of multiple machines, the first step is to always determine the break-even point for each range. In order to do this, we'll be using the break-even formula we learned in the last video and apply it to each of these machines, which gives us, for one machine, we will be needing to produce 320 units to break even. With two, we'll be needing 500 units. And with three machines, we'll be needing around 666 units to break even. However, notice here that with one machine, we can only produce 300 units. And this is less than the amount we need to break even. Therefore, this machine would result in a company losing money and should not be considered. In the second portion, we see that we have a forecasted demand between 580 and 660. So how many machines should we purchase? We already saw that one machine is out of range because it would result in a net loss. So let's take a closer look at 2 or 3 machines. If we get 2 machines, even if our demand is at the lower range of 580, we will still have a profit because it's above our break-even point of 500 units. However, if we get 3 machines, if our demand is at the higher end of 660, it will still be well below our break-even point of 666. Therefore, in this scenario, the optimal number of machines will be 2. And with that, we've concluded this video series on Chapter 5, Capacity Planning.